Okay, so today I want to discuss some breakthrough I've made on looking at the Zoom ZDL files. And this is for my B1ON, and so it's the older file of FX used on the B1ON, the G1ON, and I believe the G3, G5. I only have the B1ON, and I managed to win an eBay auction for a G5. So let's have a look at what I've managed to find. Yeah. So it was based on playing with the unofficial Zoom Effect Manager 1. You can install this on a PC, say. I would recommend installing it on a little VM where you can allow the MIDI or USB to talk through to it, and you can keep it isolated, okay? Um, and then it allows you to inject ZDLs into the firmware and load them onto your pedal, and it's worked very well on my B1ON. The only thing is the excellent tone lib just doesn't understand the new effects, and this is a common complaint that people have. If you've been following some of the other stuff I've been doing on the newer series, the B1X4 and the B3, the G3, and lately the GCE3, Munjal made excellent progress in the early days on the original pedals, and I've taken up the gauntlet to play with the newer pedals and put some GUIs on it. And what he does is he looks for a FLST, which I guess is like a file system sequence, and it's a ZDT for I guess a Zoom text or Zoom table, file table, and he can retrieve it with MIDI from the pedal. And this gives a list of FX in the group order, and then some sort of alphabetical order after that, and returns what Zoom call the type of an FX, which is really a concatenation of the FXID and the group ID, although you have to do some bit manipulation to get it right. And it also gives the name and version. Now, what we discovered is the older pedals also have an FLST sequence, but these are only returning the group ID and the alphabetical list. They don't return the type. Um, Also, we haven't found, or I haven't found the way to get to this via MIDI at the moment. It might not have been implemented because it's an older pedal. So I started looking at the Zoom Effect Manager, and finally I worked out how to get the symbol info from the Zoom firmware. And then, as long as you have a non-corrupt ZDL, you can get the information that we need. So that's what this video is about. Um, so let's look at the ZoomPedalFun website that I put together. And if you go underneath it, you'll find there's a derived data. So all the information will be available from here eventually. And here is where I put a README. If you use some Python, Python's quite neat for doing this sort of stuff. There's a program called C-split-B, which you can get from pip install. And it looks like that what they were doing in the effect manager at least is looking for 4 null hexes. So this is 4 hex bytes, and then this 5359, which 53 is an S, isn't it? So there'll be some sort of number, some sort of format there. And what I can do when I do that is pull out a series of ZDLs, and you see this is coming directly from the 1.3 system updater. Okay, and this thing says use 3 digits in the number, make it FX as the prefix, and make it Z dot ZDL. You need to put a dot in as the postfix. Yeah. So this pulls out a series of information. Okay, and off you go and get some stuff. Okay. Now, more importantly, on what I did is I pulled the Zoom Effect Manager stuff across from the laptop or from the Windows box to the Zoom, but to the Raspberry Pi. And when you unpack the Zoom Effect Manager, there's a files and then FX. I can't say it properly, but it's fully English EFFEX whatever. And inside it, what you have is the things like the Holly Thrub and the Hotbox. And so this is a whole series of ones that the chap has managed to find throughout, the internet. And these FX ones are the ones I pulled out from the method just shown. Okay, so what I do is I look for the FL sequence, which you can find inside, and I pulled out the name. So it has opcomp, decomp, blah 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 blah. So, and in fact, I have a feeling. Give me a second. I put that here. So on this one here, FX GID text. This one is where, sorry, so this one here is where what we've done is we've taken all of the dumps from, Well, what I've done is to take a patch and I load up the first FX, in this case opcomp. Then I let the sysx set all the values to 0, and what's left is the first 4 digits 61000002. Then I set the FX to decomp and repeat the process, and it's semi-automated. Okay, I got a video about that earlier. So I can pull out what comes through the net once you've injected the FX into slot 1 of a patch and then pulled it down. So this is what we get coming out, and set of numbers. Great. So then what happens is that if we look at the catalog dump, we can begin to see this stuff coming out from the FLST sequence. So what this thing is inside the angle braces is the previous folder, and this is the current folder. So what it says is that folder 1 is opcomp, decomp, whatever. If we look here, we find that these have got 0, 2. Okay, so we have to halve that number for whatever reason. Okay, I guess it means that the bottom bit is set for something. Okay, now then what it says is what was folder 1 becomes folder 2. So now we get this stuff, and I make a note here: if the second, so 0, 1, 2, 3, or byte 1, byte 2, byte 3, byte 4. So if this byte here is 0, you just halve that. If it isn't 0, and it's got to be bigger than C0, because this 20 screws things up. So as long as it's bigger than C0, so you just have to AND it with C0, and if you get a hit, then you do something special. So basically what we're saying here is that, let me just scroll down, if it gets bigger, if that's got a bit set with C0, you concatenate the bytes together. In this case, the 8002 becomes 280, and you right shift it by 5, which is divided by 32, and you get 14. Now look, that's the number there. Seems rather neat to me. And same here, you've got this 2CC0, which becomes 16 by the time you've shifted it. Now, this was the one that gave me some angst, yeah, because the 16, the SVT, these are the AMP models. So if we go back and look at those, the AMP models have got 20 OA, and for whatever reason, we don't want to take this high byte into account. It gets crazy numbers. We just want OA from that. So if we do that, we get OA is 10, and when you divide it by 2, it's 5. And that's exactly what we want for the group IDs. So this was the next progress that I made. Okay, we got some idea of some of the structure inside it. But then, for whatever reason, I started looking at the patch dumps, and or specifically the ZDLs rather, and I realized that if we start with these 4 nulls as the original marker followed by that pattern, then bytes 40 hex to 47 give us the FX GID and the version. And we also know from previous work that 30 bytes on from the on-off start gives us the name. So let's just have a quick look. I think this one here rather is where I tell you about the new decode version. So there we are. Yeah, so I've done exactly what I said. I've gone into the original file, in this case opcomp, and I said, hey guy, show me what's happening at byte OX40, and then at OX41, at 42, 43, 44, etc. And when I do that, the last 4 gives me version 1.00. It gives me group 1 when I do some messing around with it, and OX30. Well, hang on a minute. Let's look at what that is. So you can see we said that we need to divide that by 2, and sometimes we need to concatenate this number on and right shift it by 32, yeah? So we know how to get that bit. But this byte is 2 times that plus 1. And when we play with the sysx, the FXID input, when we put in the number x, what we get is either 2x or 2x plus 1 in this position, depending on whether we flip an on-off bit. So what this means is that it makes a lot of sense. So these are the right numbers coming out. So let's look at this in code. Again, that this is quite detailed. I'm sorry if you're just looking for gratuity effects, but this isn't how I roll, yeah? So let's look at ls star.py for Python. And what we can see, we have a check me. So let's look at the check me.python. And what it does, it says, okay, get, make that a bit bigger. So it says, get a name coming in and pass that to check. And what check does is it says, hey man, read in that file. It's all very trusting, by the way. Read in that file. Take the first 64 bytes, which is OX40 in hex, and then read 8 more bytes, and then just read the whole file, okay? So, I mean, I could do that in the first case, doesn't matter. Then we say, okay, go and look for on-off encoded as ASCII, or in fact as binary, in this data, and that's the start. Set the name to null, and go up to 12 characters, which I think is the length you can have for a FX name. And relative to the on-off start and 30 bytes thereof, as long as it's not 0, then add the character on, otherwise break. Then I'm using a multiplier of 256. Now, talking about to Manju about this, I don't know if it should be 256 or 128 at the minute. If it was pure hex, it's definitely 256, but I guess this is like 7-bit, so I don't know. I don't know is a simple answer, and I'll work it out eventually. Yeah, it's a problem of not knowing. So now we start to construct a JSON format. So we say the file name is the name we've read in, was passed in as a ZDL file name. The FX name we've just derived here. If that second byte, well, third byte but second index, yeah, so 0, 1, 2, 3 is the same as byte 1, 2, 3, 4. So byte 3 is position 2. So if that byte is C0 or bigger, in other words, if the top 2 bits of the nibble are set, then we do this decode where we put them together. So we take the other byte as the higher byte, multiply it by the multiplier, add on the ANDing there, and then we divide it by 16 in this case. Yeah, I think that's right, 16. I said 32, but I think that's right. And then basically we do the same here. In this case, if it isn't set, then we just basically put the value out and we divide by 2 somewhere. Would I do that? No, I just stick it out. I just stick it out. So I don't divide by 2 at all there, actually. So maybe... Yes. Idiot. I'm being an idiot. The reason I don't divide by 2 is because this is coming from the ZDL. It hasn't gone through the sysx process. So it's raw. It doesn't need to be processed. It's what happens when you do it. So that's why I do it this way, and that's why I also shift by 4 and don't divide by 32. So now what we do, if we look at some shell scripts, so let's look at what does check fx do. So what this does is say, hey man, remove a decode.txt, look at all the ZDLs that got the pattern fx star.zdl, run it through the process and stick it in decode fx. So let's run that, and you can see this is what's come directly from the firmware update. What does this mean? I use the pure firmware update from Zoom, but if you also use the firmware update that you create from the Zoom Effects Manager, the unofficial software, we can use that as the basis for pulling out the ZDLs and the names and the IDs, okay? So let's just run that. It runs pretty quick, at least I think it does, on a Raspberry Pi. And then we should be able to look at decode FX. So this is in a sort of JSON format, but not quite correct. I would need to put commas into it, and that's very easy to do with sed. So let's vim decode FX. Oops. Now you see it says, okay, that first file you found was ZNR, and it thinks it's 51 on 1.0. Well, okay, let's have a look, see what we've got for ZNR. There we are, 51 1.0. Yay. So we can get the information. This one it says is ZSyn, wherever that is. I guess we could Control F for ZSyn. There it is. And I think that's 97.1. Yep, 97.1. So these numbers here is what you would pass in to the FXMID to set that, but unfortunately I don't know how to set the GID. and just passing the numbers in as you would on apparently a G5 or whatever only sets the FX. It doesn't set the GID. As I said, I've got the FX G5 on order. Should turn up next week, I hope, and then I can start to play with that. But basically, we can go through and find all the FX from a dump, whether it be an official dump or a correct unofficial dump. And so now we'll know the name of the FX and that. So let's look at what happened with the FSCS. So let's have a look for another check star. So we've also got check me. So what's in check me? Uh, dot shell. So this one here uses the FL sequence. So if we do more of the FLST sequence, this was derived from the pedal. I think on the web page I need to make that 160. I made a mistake somewhere. So this is what, when you look through the dump, this is what's in the um, sequence. Okay, so if we run check me, it will do the same sort of thing, but it will pull them out in the ZDT format. So if we vim, what was it, FX? No, decode FL, that should be it. Now you see we've got the op comp is 30. So now when we look at the thing, oops, sorry, mouse went wrong. When we look here, we go to the top. This should be in order that the FL sequence has put it onto the pedal. Okay, so let's have a quick look. Bop, 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 bop. So we should have the, yeah, there we are. The op comp, the D comp, the M comp, the 160 comp, the limiter, the slow attack, the ZNR. So now what I assert is that we can get the type, as they call it, and what I'm calling, well, the split type is the FX and the GID. The type is the full concatenation. So we're able, even with these old pedals, to get the values. I mean, all we've got to do is to put some commas in here and some square brackets around it, and then we can read it into a program. So just to recap on the Zoom pedal, I can set this first two digits would would a sysx, but I can't set these. If only I could work out how to do that, then we would be able to take a pedal that we have the firmware for, and we'd be able to derive the state of the pedal in terms of the FX that's on board. We already be able to work out the patches, and we'd be able to inject new patches in and change them. So that's where I am at the minute. That's all I want to say. Sorry for the long rant, but I just wanted to show you how I went about doing it. It was all a bit kinky. It just came down to just staring at the ZDL individual dumps from the unofficial effects manager, and then just spotting that these numbers were double what was already in the actual ZDL, and that's not surprising. I'm kind of annoyed at how stupid I've been up to date, because I already knew that when I put X in, I got 2X plus. I either got 2X or 2X plus 1 out of it. Yeah, so I already knew that. I just wasn't thinking about the fact that rather than looking for hex 61 in opcomp, I should look for hex 30. And that's how it is sometimes. You can see you can't see a pattern. It's right in front of your eyes, and then you see it. So that's really all I want to say. Thank you for listening, and yeah, should be more on this front as we get it. Okay, cheers. Bye bye.